Hi, my name is Fuja.
And I'm Stephanie.
We work on question answering systems. QA is an important topic because it is a very common need in real life. Many tasks can be formulated as QA problems, such as machine translation and relation extraction. Also, QA helps us understand other related NLP tasks in general. Past approaches in this field including information retrieval-based QA and knowledge base-based QA. The key difference between the two approaches is that whether the source of search is unstructured or unstructured data, whether we use logical forms or keywords to identify relations between entities.
In our approach, we combine both of the previous approaches of question answering over structured and unstructured data in an efficient way. We use Freebase as a knowledge base for structured data and then Wikipedia as unstructured data. In our first step, the entity linking step, we identify entity mentions in questions and then use these as keywords to search for the top 7 candidate entities in our knowledge base. The features that we use in this step include part of speech tagging from the NLTK library and then entity scores based on their search retrieval count from the knowledge base.
After we have identified the most likely entities in a question, we want to extract its relations to the possible answer entities. In relation extraction, features that we use include dependencies parsed from Stanford Dependency Parser. For a given question, 2 types of features are extracted: syntactic features and sentential features. Syntactic features consist of dependencies and the shortest path from question word to its entity. Sentential features capture the structure of the question. We use GloVe 50 to represent words, and we feed the extracted features into a neural network to predict relations.
In the joint extraction step, we attempt to combat error propagation stemming from the entity linking step to the relation extraction step, and we do this by ranking a list of entity relation pairs based on an SGD classifier. The features that we use are extracted from entities, relations, and candidate answers.
We use Web Questions dataset, which consists of 58,100 questions in total. The original paper uses Freebase, which contains 4 million entities and over 5,000 relations. Here we use a small subset of the original database. Our own Freebase has over 46,000 entities and 16 relations.
Our first result set for the entity linking step is 2 different accuracies. The first accuracy is based on questions handcrafted from our small knowledge base, and this received a score of 93.8%. And then the second one, which is questions from the KB train data, which is what the paper used and is still searching on our small knowledge base, is 26.6%. The much lower score is a result of the fact that the step is heavily dependent on information in the knowledge base, and ours is very small. So it's obvious that we need a much larger data set.
For relation extraction, we trained a 2-layer feed-forward neural networks of size 100 each for this multi-class classification problem. We trained our model on a subset of the dataset, which consists of 150 data points. The plots showed that both train and test errors converged to close to 0. Yet this could be the result of overfitting since we only trained it on a very small subset of data but using a rather large size of neural networks.
One obstacle we need to overcome is the separation of entity mentions in the entity linking step. In this example, the last name Rossing isn't included because it's considered a verb according to part of speech tagging. We realize that missing last names as search keywords can be very detrimental to the entity linking step.
When implementing relation extraction, obstacles we're facing are first, dependency parser is extremely slow. Also, GloVe does not contain any of the dependency terms, therefore we just use the word representations for their service forms.
In the future, we hope to improve our scores by expanding our extremely limited knowledge base by using an API such as Google Knowledge Graph. And then we also need to add the answer inference step so that we can validate candidate answers over an external unstructured data source such as Wikipedia.
Thank you.
Thank you.